Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on June 16, 2025. So, published just a couple of days ago, it makes the striking claim that a new class of models can achieve up to 10 times the inference speed of their traditional counterparts. The paper is titled Discrete Diffusion in Large Language and Multimodal Models, a Survey. Alright, so this paper provides a big overview of what are called Discrete Diffusion Language Models, or dLLMs. These are positioned as an alternative to standard autoregressive models. You know, the ones that generate text one word at a time. Instead, these new models use a denoising process to generate multiple tokens in parallel. This approach not only makes them much faster, but also gives developers more fine-grained control over the final output, and as we'll see, the results are quite impressive. Also, the authors shared their work on GitHub, and it's a fantastic resource for anyone interested in this area. You won't find a single model implementation, but rather a comprehensive, living library of all the papers they surveyed, all neatly organized by topic, from training techniques to applications. And this figure here really gives you a bird's eye view of the entire research landscape being surveyed. It's essentially a mind map, starting with the core idea of discrete diffusion models and branching out. We see the fundamental mathematical formulations, like the discrete denoising diffusion probabilistic model, or D3PM. This is the core engine, which works by taking clean text, systematically adding noise, and then training a model to reverse that process. The map also covers training and inference techniques, and even a wide range of applications, from text generation to biological and drug discovery. Alright, and this next figure does a fantastic job of showing the core differences between these two approaches, side by side. On the left, you have the standard autoregressive model, and on the right, the new discrete diffusion model. The key difference is in what's called the attention mask, which is like a set of rules that tells the model which words it can look at. Autoregressive models use a causal attention mask, meaning they only see past words. But these diffusion models use a full attention mask, letting them see the entire context at once. This allows them to fill in multiple words in parallel, which is where that massive speedup comes from. Building on that, this figure visualizes the different unmasking strategies these models use to generate text. Think of it like solving a puzzle. The model starts with a sentence full of blank spaces, or masked tokens, and has to fill them in. It doesn't just go left to right. Instead, it uses clever approaches like confident decoding, where it first fills in the words it's most certain about, no matter where they are. Others, like the top street strategy, reveal a fixed number of the most likely words at each step. And with all these new techniques emerging, it's really no surprise to see the research community taking notice. This next chart drives that point home, tracking the number of publications on ARCS-14 related to discrete diffusion over the last few years. You can see a clear, almost exponential growth, especially from 2023 onwards. The research is also getting more specific, moving from general discrete diffusion models to focusing specifically on language and even large language model applications. This trend really underscores just how much momentum this entire field has right now. So to wrap things up, the big takeaway here is that these discrete diffusion language models, or dLLMs, are a really powerful alternative to the standard autoregressive models we're used to. Instead of generating text one word at a time, they use this clever denoising process to generate multiple tokens in parallel. This parallel generation is the key. It not only makes them significantly faster, but also gives developers much more fine-grained control over the final output. It's a really exciting space. That's all for this week's AI Research Roundup. Thanks for tuning in.